Hello, in today's video I'm going to be going over some tips and tricks so you can successfully print ABS at home. Now this will be the first in a multi-part series of videos. This will be going over some of the basics to help you prepare for printing ABS, and we'll be going into some more in-depth stuff in later videos. Now, printing ABS compared to PLA and PETG, it can be harder than those other plastics. However, if you prepare and you go into it knowing some basic information, you can do it successfully. If you go into printing ABS blind and you take no prep work, you're going to end up with frustration and you're going to have a bad time. So the first thing you can do if you want to print ABS at home is ensure you are starting off with a good filament. There are multiple different brands of ABS out there. However, the first thing you should not do is go on a filament vendor site or Amazon.com, search by the cheapest and buy the cheapest ABS you can. Most filament manufacturers do not make their own plastic. They simply buy bulk resin from plastics manufacturer and extrude it into filament form. When you buy cheaper filaments, especially off Amazon and other third-party sites, you're most likely buying a really low-grade ABS, and that's usually also the ABS that smells really bad. Good quality ABS, while it does not smell anywhere near as bad. And good quality ABS, you're going to have a much easier time printing. Some good brands, for example, are KVP, Paramount, Matter Hacker, eSun, Hatchbox. But either way, just make sure you buy a good quality filament. It'll make things much easier. Depending on where you are in the world, you may need to consult with a local 3D printer group because availability, of course, is going to be different wherever you are in the world. Now, one thing I will recommend in the plastic we will be using for this video series will be eSun ABS Plus. This is an ABS Plus blend. Most ABS Plus blends have additives to it to make it a little bit easier to print. And eSun ABS Plus is basically cheating when it comes to ABS. It prints so forgivingly that it will make printing ABS, especially for those that have never done it before, much easier and much simpler. Now, there are also filled ABSs and other brands of ABS Plus. I won't be going over those. They'll make the video series too long and complicated. This is an intro series, so we will be using eSun ABS Plus. Now, the next thing you have to make sure is that your printer itself can print ABS. There are some requirements that your printer has to meet to print ABS successfully and safely, and I'll go over those now. Now, the first thing you are going to need is a hot end that is all metal. You cannot be using a PTFE lined heat break in your hot end. So, for example, a stock Ender 3 with its PTFE heat break cannot print ABS. At the temperatures you're going to be printing ABS at, and that's anywhere from 240 to 250, plus minus a couple degrees, depending on the filament and how your tuning is. At those temperatures, you're going to be breaking down the PTFE liner of the heat break. And when PTFE breaks down in the heat break, it does two things. One, it'll degrade your print quality, and two, and more seriously, it's going to release noxious and toxic fumes. That is Teflon overheating, essentially. So we do not want that. Now, there are multiple ways you can get around that. You can make sure your printer, if it already has a full metal hot end, then you're fine to go. If you have a PTFE lined heat break, you can swap out the heat break. I know on, for example, an Ender 3, you can simply swap in a Chimera heat break that's all metal, and you're good to go. Or you can replace the whole hot end. For example, you can get a Dragonfly or other full metal hot end and swap that into your printer as well. Now, for nozzles, as long as you're not printing a plastic with any abrasive in it, I'm going to recommend either a brass nozzle or, my personal choice, a copper plated nozzle. So that's a copper nozzle with a plating on it that offers excellent heat transfer. And as long as you get a good quality one, I use Triangle Labs ones myself. They print excellent. I use them on all my printers that don't print any abrasive materials. They are great nozzles. But a standard brass nozzle will do as well. You don't need to worry about getting a vanadium or Nozzle X or a hardened nozzle for printing regular ABS. Now, the next thing is your bed. You are going to need a heated bed. There are materials out there that advertise as beds that don't require heat for printing some plastics, and there are some additives and liquids that you can put on your bed to help adhesion. However, you will need a heated bed to print ABS successfully. Now, while you may be able to get by printing ABS without a heated bed, once you start to get taller objects, larger prints, you're going to start running into issues with layer delamination and layer adhesion. Without the heat, the plastic will cool down and it will pull away from itself as it's printing, and you're going to end up with warped parts, layer delamination, and cracked prints. Now the printer we're going to be using for this video series here is my Bonsai. For those that are a frequent viewer of this channel, and if you're not, make sure you are subscribed so you can follow along. This was built on a few live streams over the summer there, and we got it up and functional. Now this is a design found on Thingiverse. It is built out of some spare parts that I had kicking around and some parts I purchased. One of them was the heated bed. Now the bed on this is nothing special. This is only a 60 watt, 12 volt PCB heated bed. All I've done is gone ahead and installed a removable PI sheet covered spring steel flex plate. But other than that, this is the stock bed. The hot end is a Triangle Labs V6 with a 30 watt heater cartridge and a titanium heat break. You don't need the titanium heat break, I just had one on hand. This printer again was built mostly with spare parts that I had. The extruder is a simple Mark 8 extruder gear on a NEMA 17 motor direct feed. We have a SKR Mini E3 V1.2 controller board with TMC 2209s, and it is running Clipper on a Raspberry Pi Zero. Now the reason I'm using this printer and not, for example, my Voron V2 here, is my Voron V2s pretty much eat ABS for breakfast, lunch, and dinner. That's all they do is print ABS, so they're fully tuned for printing that filament. This printer right here is more in line with what you will see out there among other people. It's an i3 Mendel style printer. It's got 12 volt power. This thing right here, if we can get this printing ABS, and I've already done it, it does print ABS just fine. You should be able to do it on any printer that you have at home as long as it meets the minimum requirements for printing ABS. Now the last thing you are going to need for printing ABS successfully is an enclosure of some sort. Now depending on what you are looking to print, it could be as simple as closing the vents in your room, closing the door and leaving the printer alone while it prints a small object on the bed. Or you can get as far as building a full dedicated enclosure for your printer. It depends what you're going to be doing with the ABS. Now the main goal of the enclosure is eliminating drafts and keeping the heat in the enclosure itself. Now drafts are horrible for printing ABS, as a light breeze may be enough to cool the plastic enough that it may cause it to stress and delaminate or crack. So you want to prevent as much drafts as possible. The easiest way, of course, to do that is to enclose your printer. Now enclosing your printer also helps with ambient air temperatures. With printing ABS, there is no set perfect temperature for printing ABS, but the hotter the better essentially. Once you get above 35 degrees Celsius, especially next to the bed, it becomes much easier, and then from there on, the warmer you can get, the better your prints will be, the better your layer adhesion will be. The goal is to lay your plastic down as one hot homogeneous blob of plastic and let it cool naturally as one piece. When you have major temperature differences in your plastic part, that's where you start seeing layer delaminations and bad layer adhesion. Now, if you can't print enclosed for whatever reason, what you can do is print with a wide brim and with a draft shield. This acts like a little wall around the print as it prints up, and this can keep some of the heat in, and the wide brim will help it stick to the bed surface. This can work. It really depends on the shape and size of the print. Small objects that are close to the bed will succeed, whereas, printing a large, tall object, you may start running into issues as you get higher up off the bed. Now, when it comes to enclosures, there's multiple different options. I'm sure you have all seen a lax enclosure. Those are very common. The goal is to keep the enclosure as small as possible because the smaller the air volume, the easier it is to heat up and the higher air temperature you'll be able to get in there. Now, when it comes to building the enclosure, there's multiple different materials. If you're worried about fire, for example, you can build it out of drywall or sheetrock or any fire-resistant material. If you're really wanting to keep that heat in, you can use rigid insulation that is fire-rated, for example, or you can go as simple as buying one of those pop-up white box photo booths off Amazon and putting your printer in that. Those do work, however, they are very thin, so they don't trap a lot of heat. Now, the method we are going to be using here for this video series is probably the simplest of it all. We're going to be using the box the printer came in. Now, by no means this is a permanent or fancy setup. However, it works quite well in testing. This gets up to 40 degrees Celsius, and that is with a temperature probe sitting right up here on top of the gantry. And even closer to the bed, we're looking at 45 to 50 degrees Celsius in a cardboard box fully heated by the 60 watt bed of this printer. So cardboard is a great insulator. Now, what you can also do is I have a front panel here. This is just made out of Coroplast because I ran out of cardboard. With a clear panel, And this allows me to watch the print while it's printing. Or you can go as simple as putting a webcam in there with a light, so that way you can watch the print without even needing to put a hole in the cardboard box. So as you can see, there's no room for the filament spool in here. I have a hole in the top here, so the plastic will feed down from our spool outside. You don't need to put your spool in the enclosure. That just takes up more room. Preheating the filament isn't really something you need to worry about. And with ABS, it doesn't absorb moisture as quick as nylon, so you don't need to worry about keeping it dry while it's printing for any reasonable length of time. Now with a cardboard box enclosure, I do know the issue of fire safety is going to come up. Now in my printer room here, I do have a smoke detector up on the ceiling here above the printers, and I do have a fire extinguisher. So I do take precautions in the event that anything catches fire in here. I'm notified of it and I can deal with it that way. Now this printer right here, I only run when I'm at home, especially when it's enclosed. It doesn't have as many hours on it as some of my other printers. Now all my printers also have webcams on them, so I can monitor them remotely from my computer room upstairs. And while this is a self-built printer, I do have some background knowledge in electronics through school and education and life experience. So I do believe that this is wired safely, and I've taken all the precautions that I need to ensure that it operates without causing a fire, for example. However, while I believe that I've taken every precaution that I need to keep myself and my family safe, I believe that you also should take any precautions that you believe you need to take to ensure your safety and the safety of those around you. So if you are uncomfortable running your printer in a cardboard box, don't run it in a cardboard box. You do what you feel is safe. And the second big safety issue with ABS, and the elephant in the room, of course, is the fumes. ABS does release volatile organic compounds, or VOCs, while it is printing or burning or melting. It releases much more VOCs when it is burning, but simply the act of melting it for printing does release levels of VOC as well. Now, what are VOCs? They can be bad, but really anything that you can smell is an organic compound. So when you are cooking bacon, you are releasing VOCs. When you walk by a car and you kind of smell the exhaust, that's also VOCs. Walk into a new house with fresh carpeting, you're smelling VOCs. And of course, when you're painting, you smell VOCs. So a lot of things release VOCs. Now, I have looked for the documentation to try and find out what the actual level of styrene released by a 3D printer when it is printing ABS is, to compare it to what OSHA considers safe limits. However, I haven't been able to actually find any documentation that states what the actual output of dangerous VOCs is of a printer while it is printing. So if somebody happens to find it, please link it below in the comments. So when it comes to safety with ABS and the VOCs when you are printing, I recommend you take all the precautions that you believe. Now, in my case here, I'm involved in the plastic injection mold industry. I see what goes through industrial size machines and what operators are exposed to, and compared to the levels that a 3D printer printing a few hundred grams of plastic over a couple hours does, I don't believe I'm in any serious harm having one of these running in my basement. Now, I do take some precautions, of course. I keep the air conditioning vent closed and plugged at all times. I keep the door closed when the printers are printing. And I'm really only in the room for what I need to be in the room for. I'm not living in this room. I don't have my head in the printers while they're printing the whole time. I monitor everything remotely. This has been my setup for several years now. I haven't had any issues. Of course, this is something you won't notice for years down the line. However, I take all the precautions that I believe I need to do to be safe. Now, of course, this is something that you also have to keep in mind, and you should be taking all the precautions that you believe you need to take to be safe. The fact that I can't find any solid documentation letting me know of exposure rates kind of lets me know that it's not a massive worry to have one of these running in my home, especially in its own room in the basement. Remember, even a banana can give you radiation, but it's all about the levels and exposure. So nobody's worried about getting, radiation poisoning from a banana. I need to know what the actual off-gassing levels of styrene from a printer printing ABS are before I start worrying about should this even be in my house. So I hope you have found this video interesting. If you do have any questions or comments, make sure you ask them in the comments below. The next part of this series will be going over some more advanced stuff regarding the printer, as well as slicer settings and making sure you are ready to go print some ABS. If you'd like to support the channel and what I do here, there are some links below to help you do that. And as always, be safe out there and have a great day.